Welcome to the lecture series of the subject Embedded System with the subject code KOE 062. This is an open elective being taught in almost all the branches of engineering. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject or we can say the topic that I am covering today in my lecture series is the preemptive scheduling. So, we are going through the essentials of real time operating systems, and preemptive scheduling is an important topic of the RTOS. Let us go into details. First of all, let us understand what is task scheduling. In a multitasking system, there should be some mechanism in place to share the CPU among the different tasks and to decide which process or task is to be executed, and this is very important. Because in the real time operating system, execution of every task and that too in time is very much important. So, this process of deciding that which task is to be executed when, this is very important, and this is known as the task or process scheduling. Depending upon the scheduling policy, the process scheduling decision may take place when the process switches its state to ready state from running state, or another option can be blocked or wait state from running state, another can be ready state from blocked or wait state, and it can also be completed state. So, there are these are the different scenarios when the switching from one task to another can take place. The task scheduling policy can be preemptive, non-preemptive or cooperative. So, in the I have already discussed the non-preemptive scheduling in my previous lectures, and today we are going to discuss preemptive scheduling. So, the preemptive scheduling techniques, there are three main techniques in this category. First is shortest job first scheduling. As the name is suggesting, in this process that task will be given the priority which is having the shortest executing time, or we can say the minimum executing time. Or we can say that shortest remaining time scheduling, that is known as the SRT scheduling. Another option in this category is round robin scheduling. So, in this process every task is given the equal execution time, and accordingly if there is the execution of any task is left, then again the chance to that particular task is given again. We will see in details what is happening in this type of scheduling. Third type of scheduling in this category is priority based scheduling. So, every task is assigned a priority in prior, and according to the priority assigned to the task, assigned to the different tasks, execution will take place accordingly. Let us go into details of these scheduling mechanisms one by one. First is preemptive shortest job, that is SJF scheduling, or shortest remaining time scheduling, that is SRT scheduling. The non-preemptive SJF scheduling we have already discussed, and according to that it sorts the ready queue only after the current process completes execution or enters the wait state. Why this was happening? Because this was non-preemptive. So, there was no provision of preemption of the task, but on the contrary, in this preemptive shortest job first scheduling mechanism, the scheduling algorithm sorts the ready queue when a new process enters the ready queue and checks whether the execution time of the new process is shorter than the remaining of the total estimated execution time of the currently executing process. So, what is happening? Suppose some task is being executed and it has been selected from the queue itself, and now another task has entered the queue, another new task, and the execution time of the new task is smaller than the remaining execution time of the already ongoing task. then what will happen that the new task is given the priority, is given the chance prior to the execution already executing task. Why? Because the execution time of the newly entered task is smaller than the remaining execution time of the ongoing task. So, this is how the task which is having the shortest execution time is given the priority in this type of scheduling. If the execution time of the new process is less, the currently executing process is preempted and the new process is scheduled for execution. This is what is happening. So, as a conclusion, this scheduling algorithm always compares the execution completion time, that is the remaining execution time for the new process of a new process entered the ready queue with the remaining time of the completion of the currently executing process, and accordingly it schedules the process with the shortest remaining time for execution. So, this is a very easy scheduling algorithm. Now, we will move further with an example of this scheduling mechanism. Suppose there are 3 processes with the process IDs P1, P2 and P3 with estimated completion time of 10, 5 and 7 milliseconds respectively. So, this is the situation. Now, they enters the ready queue together. Now, a new process, that is P4 with the estimated completion time of 2 milliseconds, this is the completion time, that is the execution time of the newly entered task. It enters the ready queue after 2 milliseconds. Okay. So, after 2 milliseconds means when the ongoing task has completed the 2 milliseconds, then the new task has entered the queue. Now, we have to assume that all the processes contain only CPU operation and no input output operations are involved. Now, let us see what will be the solution. What they are asking? They are asking the average execution time and the turnaround time. Let us see. At the beginning, there are only 3 processes, that is P1, P2 and P3 available in the ready queue, and the SRT, that is the shortest job first scheduling algorithm picks up the process with the shortest remaining time. Okay. So, in these tasks P1, P2 and P3, which task is having the shortest execution time? This middle one, that is the P2. So, obviously, the P2 will be chosen for the execution. Now, after executing, okay, so after the 2 milliseconds of execution of P2, in this example P2 with the remaining time 5 milliseconds for scheduling. Now, process P4 with estimated execution time completed time, that is the 2 milliseconds, enters the ready queue after 2 milliseconds of the start of execution. So, what is happening? P2 started, the total execution time of P2 is 5 milliseconds. Now, after 2 milliseconds of execution, P4 enters with total estimated execution time 2 milliseconds. Now, when P4 enters, the 2 milliseconds of execution has been completed. So, P2 is left with how much time of execution? 3 milliseconds. Now, the algorithm will compare newly entered process with the remaining time of the task which was already executing. Now, when it will compare, it will find that the newly entered task is having the less execution time as compared to the remaining execution time of the ongoing task. So, which task will be now selected? Obviously, the newly entered task. So, this is a new execution order. P2 first entered the execution order. After 2 milliseconds of execution, P4 entered. Now, P4 is given priority as I already explained here. Now, P4 is when the P4 executes, it will again take 2 milliseconds because this is the overall execution time. Now, after that the task with the shortest execution time will be selected. So, P2 is left with the 3 milliseconds of execution time and other tasks P1 and P3 are having the 10 milliseconds and 7 milliseconds of execution time respectively. So, obviously, now P2 is having the shortest execution time. So, P2 will be kept in the priority order in the execution. So, P2 will be executed after 3 milliseconds of execution of P2, then again P3 is selected because P3 is having the 7 milliseconds of execution time, and after P3 P1 is given the last priority, that is having the execution time of 10 milliseconds. So, now we will calculate the waiting period of all the processes. The waiting period of P2 is 0 milliseconds plus 4 minus 2 milliseconds, that is the 2 milliseconds. P2 starts execution first and is interrupted by P4 and has to wait till the completion of the P4 to get the next CPU slot. So, total 2 milliseconds it has to wait. Waiting time for P4, that is the 0 millisecond, because as soon as it enters the queue, since it is having the shortest execution time, so it will be selected immediately. So, in this way P4 the waiting time for P4 will be 0 milliseconds. Now, the waiting time for P3 is the execution time of P4 plus the execution time of P2. So, the that is total of 7 milliseconds. Waiting time for P1 is the execution time of for all the processes, that is P1, that is P2, P4 and P3. So, in this way it ends the total is 14 milliseconds. So, this is the total waiting time for P1. So, the average waiting time can be found out by adding all the waiting times for all the processes divided by 4, since there are 4 total of processes. Now, we come to the turnaround time. Turnaround time means the total waiting time plus the total execution time. Accordingly, we can find out that how much time each process has to wait and how much time it will take for execution. So, in this way at the last we can find out the total the average turnaround time is turnaround time for all the processes divided by the number of processes, that is that will give 11.75 milliseconds. So, in this way we can calculate the average waiting time and average turnaround time. Now, we come to another mechanism in this category, that is the round robin scheduling, that is also known as the RR scheduling. Each process in the ready queue is executed for a predefined time slot. In this mechanism, the execution starts with picking up the first process in the ready queue. It is executed for a predefined time. Okay. So, every task is given a predefined time for its execution. So, whether the execution completes in that predefined time or not, but the execution then switches to another task. So, in this way the round robin technique is planned. When the predefined time elapses or the process completes, or it can also happen that before the predefined time the execution completes, it is also the possibility. So, in that case also the execution switches to another task in the queue. So, if this happens, the next process in the ready queue is selected for execution. This is repeated for all the processes in the ready queue. Once each process in the ready queue is executed for the predefined time period, the scheduler comes back and picks the first process in the ready queue again for execution. So, this is what is happening in this mechanism. So, the round robin scheduling is similar to the first come first serve scheduling, but what is the difference between the first come first serve scheduling and the round robin scheduling? That in the round robin scheduling there is a predefined time, but in the first come first serve scheduling there was no such predefined time and the chance to another task is given only when the execution of the previous task gets completed, that is it. So, this is the difference between both the mechanisms. So, this is what is quoted here, that only difference is that a time slice based preemption is added to switch the execution between the process in the ready queue. So, this was all about the RR scheduling, that is round robin scheduling. Why this is known as the round robin scheduling? Because in this every task is given the chance in the round process, that is if the task does not get completed, then again the chance is given to the task as if all the tasks are arranged in a circle. So, that is why it is known as the round robin scheduling. Let us understand this scheduling mechanism using an example. Three processes with the process IDs P1, P2 and P3 with the estimated completion time of 6, 4 and 2 milliseconds respectively enters the ready queue together in the order P1, P2 and P3. Okay. Now, calculate the waiting time and turnaround time for each process and the average waiting and turnaround time. So, again what we have to assume that there is no input output waiting for the process, and in the RR algorithm with the time slice 2 milliseconds. So, this is the predefined time slice, that is 2 milliseconds. Now, let us understand the situation and then we will find out the average waiting time and average turnaround time. So, scheduler sorts the ready queue based on the first come first served policy and picks up the first process P1 from the ready queue and executes it for the time slice, that is 2 milliseconds. So, now when the time slice is expired, P1 is preempted and P2 is scheduled for the execution. The time slice expires after 2 milliseconds of execution of P2. So, P1 and P2 and P3 are arranged in the row, okay, in a circle we can suppose. So, average execution time of P1 is 6 milliseconds, P2 is 4 milliseconds and P3 is 2 milliseconds. Now, what is happening after the 2 milliseconds of execution of P1, the task switches, the execution switches to P2. After the 2 milliseconds of, after the 2 milliseconds of execution, P1 is left with the remaining time of 4 milliseconds. After 2 milliseconds of execution, P2 is left with a time of 2 milliseconds. After the execution of 2 milliseconds, P3 is left with the 0 milliseconds time. Now, again the execution control is sent to P1 because P1 is left with the execution time. Now, the P1 is executed for the next 2 milliseconds and it is again left with the 2 milliseconds of execution. Now, P2 is executed for 2 milliseconds and now it is left with the 0 milliseconds. P3 was already executed, that is the execution of P3 was completed. So, again the control will go to again P1 because P1 was still left with 2 milliseconds. Now, at last P1 will execute it completely and in this way all the 3 tasks are executed one by one according to the time slice. So, this is what is happening in the RR scheduling. So, now when and after understanding this process, let us evaluate that what will be the execution time, average wait time and the execution time, and hence we can find out the total turnaround time. P1 was in the queue, it executed for 2 milliseconds, then P2 was given the chance, it again executed for 2 milliseconds, then again P3 was given the chance and it was executed for 2 milliseconds. Then again P1 was left to the left with the execution time, so it was again executed for 2 milliseconds. After that P2 was executed for another 2 milliseconds, and since the execution of P2 is now completed at this point and P3 execution was completed in the prior, because the execution time of P3 was only 2 milliseconds. So, execution of P3 was completed. Now, again it will go back to P1. So, now here execution of P1 is again completed now. So, in this way all the 3 tasks were completed with the execution. How to calculate the waiting time? The waiting time for P1 was, after the execution of P1, it then again waited for the execution of P3 and then the P2. So, it waited for total of 6 milliseconds. What was the waiting time for P2? It waited, the waiting time was the total of the waiting time for P1 and then for P3 again. So, the total waiting time was 6 milliseconds. Waiting time for P3 was the total waiting time of P1 and P2, the total execution time of P1 and P2, and that was the 4 milliseconds, because both were executed for 2 milliseconds each. So, this was the total waiting time for all the 3 tasks. Now, the average waiting time can again be found out by adding all the waiting times for all the 3 tasks and dividing it by 3. In this way, we can obtain the total waiting time of 5.33 milliseconds. Now, to find the turnaround time, we have to add the waiting time of each task plus the execution time of that particular task. And so, accordingly for P1 task, the turnaround time is 12 milliseconds, for P2 the turnaround time was 10 milliseconds, and for P3 it was 6 milliseconds. To find the average turnaround time, we have to add all the turnaround times for the 3 tasks and we have to divide by 3 because there are total of 3 tasks. So, this was all about round robin scheduling mechanism. At last, we will consider the priority based scheduling mechanism. It is same as that of the non-preemptive priority based scheduling except for the switching of execution between the tasks, because this is the preemptive scheduling. So, in the preemptive priority based scheduling, any higher priority process entering the ready queue is immediately scheduled for execution, whereas what was happening in the previous case, that is a non-preemptive scheduling, that any high priority process entering the ready queue is scheduled only after the currently executing process completes its execution or only when it voluntarily releases the CPU. So, this was what this is what was happening in the non-preemptive scheduling, that even if the higher priority task was entering the queue, it was not given the priority until and unless the already executing task has been completed. So, this was the disadvantage of the non-preemptive scheduling. So, in this case, in the preemptive priority based scheduling, the priority of a task or process is preemptive priority based scheduling is indicated in the same way as that of the mechanisms adopted for the non-preemptive scheduling. So, the process of assigning the priorities in this case also is same as that in the non-preemptive scheduling. Let us understand this scheduling mechanism using an example. So, again we are dealing with the 3 processes, that is process IDs P1, P2 and P3 with the estimated completion time 10, 5 and 7 milliseconds and priorities 1, 3 and 2 respectively. And we have to understand this, that the priorities goes on like this, that 0 is having the highest priority and so on. So, now a new process P4 with estimated completion time of 6 milliseconds and priority 0 enters the ready queue. As we can see, the task with the priority 0 is giving the highest priority. So, it enters the ready queue after 5 milliseconds of start of execution of P1. So, again we have to find the average waiting time and the average turnaround time. Let us see what will happen. Suppose all the 3 processes have entered the process, I have entered the queue, and among these 3 processes P1, P2 and P3, P1 is giving the highest priority because it is having the priority 1. So, it gets executed for 5 milliseconds and after that, so P1 gets executed for 5 milliseconds and after that another task, that is P4, enters the queue with estimated completion time 6 milliseconds, okay. And since it is having the priority 0, so it is giving the priority over the already executing task P1. So, P4 will start executing. So, what is happening now, that P1 was executing. After 5 milliseconds, since P4 with the higher priority entered the queue, so it was given the task, and until unless it got executed completely, that is for the 6 milliseconds, then again P1 was given the chance because it is having the priority higher than these two, P2 and P3. So, again the as and when the P1 is completed after 5 milliseconds, then P3 is given the chance because it is having the, in the priority order, it is the next task to be completed. After execution of P3, then lastly the P2 is given the chance because P2 is having the lowest priority, that is priority 3. So, in this way all the 3 tasks are completed. So, now we will calculate the waiting period of all the tasks. So, waiting period of P1 is 6 milliseconds because as soon as the P4 enters the queue, the P4 is given the chance because it is having the higher priority than P1, and until unless it got completely executed, that is for 6 milliseconds, the P1 had to wait. So, in this way P1 is having the waiting time of 6 milliseconds. Now, the waiting time for P4 is 0 milliseconds, because as soon as the P4 enters the queue and it is having the priority of 0, that is highest priority task. So, it is given the chance immediately and it does not need to wait for any other task to get completed. So, P4 is having the 0 waiting time. Now, the waiting time for P3, it has to wait till the completion of both the tasks, that is the P1 and P4. So, P1 execution time of P1 is 10 milliseconds and execution time of P4 is 6 milliseconds. So, total of 16 milliseconds P3 has to wait. Now, the waiting time for P2, that is the execution time of P1, P4 and P3. So, 5 plus 10 plus 6 plus 7. So, this leads to 23 milliseconds, and in this way the P2 has to wait for 23 milliseconds. To calculate the average waiting time, the total waiting time for all the processes divided by number of processes. Now, again to find the turnaround time, we have to calculate the total waiting time plus the total execution time for each of the tasks, and as a result we come for that is the P4 is having the 6 milliseconds of turnaround time, P3 is 23 milliseconds and P2 28 milliseconds of turnaround time. The average turnaround time is found out by adding all the turnaround times of the processes divided by the number of processes. This leads to 18.25 milliseconds. So, in this way, this was all about the priority based scheduling. We come to end of this lecture with the completion of all the mechanisms under the category of preemptive scheduling. That is all for the day. Thank you.